So today's notes are on solving quadratics by factoring. It's our lesson 1 for this unit, but it's section 4.5 if you're looking in your book. So it's lesson 1, section 4.5, and our objective is to solve quadratic equations by factoring, so tying right back into what we were doing last unit. Our language objective will be to use the correct terminology to explain that process. So I want to back up and sort of give you some of the vocab we need to talk about these things. This unit is focusing on quadratic functions. And so a quadratic function, singular, is a function that can be written in the form ax squared plus bx plus c, where a is not equal to 0. So it's when there's an x squared, it can be written in this form. And so that brings us to our next vocab word, the standard form of a quadratic. And that's just this form, but f of x or y equals that. So we can say the standard form of a quadratic is y equals ax squared plus bx plus c. That's our standard form. And today, as you saw in our objective, we're trying to solve quadratic equations. So what that means is solve a quadratic means to solve for the x-intercepts or zeros. Which is when y is equal to 0. So other ways you might hear this or solve a quadratic referred to is solving for the roots, zeros, or solutions. But ultimately, your goal will be the same. These are all ways of saying x-intercept. But your goal is the same. It's to solve the quadratic by solving for when y, or by getting y equal to 0 and then solving out for x. So your goal is to get y equal to 0 and solve out for x. And there's 4 ways that we're going to learn to do that this unit. So those 4 ways include, first, as we're going to learn today, factoring, which we've already learned how to factor, but we're going to tie this into how to actually solve them. Second, we have graphing, but this will be done with a calculator. So we're not really going to focus on that this unit, but if you're curious, I'm more than happy to show you how to do that. The other way we're going to learn is with the quadratic formula. And then last is, but not least, completing the square. So these are the 4 different ways you can solve a quadratic. So just like there are 4 ways to solve a system of equations, there are 4 ways to solve a quadratic. And these are the 4 ways that we can do that. Today we're focusing specifically on factoring. So to solve by factoring, I'll move this up so you guys can see it. So to solve by factoring, there's an important concept we need to touch upon. It's called the zero product property. So I will refer to this a lot throughout this unit, but the zero product property says that if A times B is equal to 0, then either A is equal to 0 or B is equal to 0. So what this means, if 2 terms are being multiplied and they are equal to 0, then the only way that can be true is if one of those terms is equal to 0. So if I'm multiplying 2 things and they equal 0, one of those 2 things is equal to 0 for that to be true. So the way this comes up, we'll show in our next example. I'm going to flip the page so I have plenty of room for this. Make sure you have this down. But in our example that we're going to do, I want us to solve x squared minus 5x plus 6 equals 0 by factoring. I'm not going to write by factoring, but no, it's by factoring. So the first thing we need to do, step 1, make sure our equation, or set our equation equal to 0. In this problem, it's already done, so we don't need to worry about it. but you can't use zero product property unless your expression is equal to 0. So we're going to need to use zero product property, and we can't do that unless our expression is equal to 0. So we first need to solve out so our equation is equal to 0. Now that we've done that, so we have x squared minus 5x plus 6 is equal to 0. We're going to, step 2, factor. So using what we learned last unit, we're going to factor this. Since my a value was 1, I know I'm going to have two binomials, both starting with x. And I'm finding factors of positive 6 that multiply or that add to negative 5. So those are going to be negative 2 and negative 3. And that's still equal to 0. So at this point, this is where zero product property comes in because I'm multiplying these two terms, so x minus 2 times x minus 3, and they're equal to 0. So I'm multiplying two things and they're equal to 0. So I'm going to use the zero product property. And I know either x minus 2 is equal to 0 or x minus 3 is equal to 0. So when I say use the zero product property, I mean set your two binomials equal to 0 or your two terms equal to 0. And now I can solve out for x in each one. So now my last step, solve for x in each equation. So I know x is either equal to 2 or x is equal to 3. So I'm done. These are my solutions. If I wanted to make sure they worked, I could plug them back in. So I'd get 2 squared minus 10 is going to be 4 minus 10, which is negative 6, plus 6 is 0. And then 9 minus 15 is negative 6, plus 6 is 0. So those work out. If you want to do out the math, you can. But this is the main point. We factor it, set each term equal to 0, and solve for x. So we're going to do a quick check with that now. I want you to again solve by factoring x squared minus 7x equals negative 12. So a little bit, one different added step, but make sure you try that out now. Pause it if you need to. I'm going to go over it. So the first thing we need to do, as our last problem said, we need to set this equal to 0. So to do that, I'm going to start by adding 12 to both sides. So I end up with x squared minus 7x plus 12 is equal to 0. Now I can proceed with factoring. So I'm finding factors of 12 that equal negative 7 since my a value is 1. So I know x goes first in each. Factors of 12 that add to negative 7 would be negative 4 and negative 3 because they both need to be negative, multiplied to a positive. So then I'm going to say x minus 4 is equal to 0, x minus 3 is equal to 0 using my zero product property. And I solve out and get x is equal to 4 or x is equal to 3. So those are my solutions for that problem. We'll do one more just to make sure everyone's on the same page because this is a critical lesson. So what if a is not 1? Let's try that out. So I have 3x squared minus 16x minus 12 is equal to 0. So go ahead and try that one out now. I'm going to go over it. So this time, since a is not 1, I'm going to do a times c, which is going to be 3 times negative 12, which is negative 36. And I'm finding factors of negative 36 that add to negative 16. Those are going to be negative 18 and 2. So then I'm going to use my middle term splitting method. I get 3x squared minus 18x plus 2x minus 12 is equal to 0. I'm going to group my terms and pull out the greatest common factor from each. So when I pull out the greatest common factor here, I take out a 3x. I'm left with x minus 6. Here I'm going to factor out a plus 2, and I'm left with x minus 6 again, which is exactly what I wanted, as x minus 6 becomes my first term and 3x plus 2 becomes my second. So now I've factored successfully. I'm going to use my zero product property, so I know either x minus 6 is equal to 0 or 3x plus 2 is equal to 0. I solve out for x and I get x equals 6, or 3x equals negative 2, meaning x is equal to negative 2 over 3. So these are my solutions for that quadratic. All right, make sure you write down questions, comments, concerns on this. I'm going to go over, actually, we'll do word problems together in class. Make sure you write down questions, comments, concerns so we can go over them together then.